Hi guys, welcome to my channel. In this video we are going to solve a question about the structural analysis, and the question will be analyzed due to moment distribution methods. Now we can see in the question it is written, and we have a beam with 3 supports, and we have a different modulus of elasticity and inertia ratio. Now we can see 2 to 3, and so let's solve the question. First I'm going to calculate the stiffness factors. For the stiffness factors, it's going to be K BA. For BA, look at here. We are going to use a modified formula because it ends with pin. Okay, so if it is pin, we are going to use the modified formula, and it's going to be 3 multiplied 2EI over length. What is length? Length is 8 meter. It's going to be 0.75. Okay, and so KBC 4 multiplied 3EI over 8, 1.5 as stiffness factors we have. So let's determine the fixed end moment. For fixed end moment, BA, it's going to be 3 multiplied P, what is P? 20, and multiplied with L over 16, and this is going to be equal to 30, okay? And for fixed end moment, BC, it's going to be WL square over 12. So 3 multiplied 8 square over 12. And this is going to be 16 minus 16. Fixed end moment CB equal to 16. Yeah, so let's write the fixed end moments. So it's going to be, for example, 30. This is going to be minus 16. This is going to be 16. And I have here is the fixed, so the distribution factor is 0. And this one is 1. And we use the let's determine the distribution factor for BA. So 0.75 over 1.5 plus 0.75, and this is going to be equal to 0.333. Okay, and distribution factor for BC, 1 minus 0.333, it's going to 0.667. So now we got the distribution factors and fixed end moments. So let's distribute these moments. I'm going to take the summation of this both moments. I won't make any carryover to this side because I use the modified formula. So 30 minus 16 multiplied 0.33 and multiplied minus 1. Okay, so I'm going to take as a result of this multiplication minus 4.662, and this is going to be this one. Okay, and it's going to be calculated like that for this one also. 30 minus 16 multiplied 0.667 and multiplied minus 1. And this is going to be minus 9.338. And I'm going to make a carryover, so I'm going to take the half of this moment. So minus 9.338 over 2, and this is going to be equal to minus 4.669. We can't make any carryover to this side because we use the modified formula. Okay, modified. So I'm going to take the summation of the moments from the fixed end moment until the last carryover, and this is going to be equal to 25.338. This is going to be minus 25.338, and this is going to be 11.133. Sorry, no, 11 point. Sorry, 1 second. Yes, now it's correct. So now we got the moments. Let's determine the shear forces, the reaction forces also, and then we are going to draw shear and the moment diagrams. For the first part, for example, this is A and this is B. I just have a moment here as 25.338, and I have a force here at the midpoint of the beam, 20 kilonewton, and I have a AY and I have a BY, okay? So now I'm going to take the moment with respect to A equal to 0, minus 20 multiplied 4, and minus 25.338, and plus BY multiplied 8, this is 4 meter, and BY multiplied 8, whole length, equal to 0, and BY is going to be equal to 13.17 kilonewton. Now we obtain BY. Let's write the total Fy equation. Total Fy equal to 0, and 20 minus 13.17 and minus AY, it's going to be equal to, sorry, this is 0. 1 second. I did something wrong. This is equal to 0. And from here, I'm going to obtain as AY equal to 6.83 kilonewton upward direction. Now, now I solved the first part. So let's solve the second part. For the second part, I have here as B and C, and I have a moment from B to C as 25.338, and I have a moment here 11.331. I have a force as distributed. Let's check what is the value of that force. 3 multiplied 8 is 24. So, sorry, 24 kilonewton. And I have a BY. I have also a CY, and also I have a moment at C, okay? So, because let's check the shape, and this shape is fixed, so it's going to be a moment here also. And I have a moment. Ya burada niye saçmaladın ya? So let's take the moment respect to B equal to 0. Respect to B, it's going to be 25.338 minus 11.331, and this length is 4 meter, and this length is 4 meter because when you convert the distributed load to the point load, it's going to apply it at the midpoint of beam. Okay, so for this from B to C, and it's going to be minus 24 multiplied 4 and plus CY multiplied 8 is equal to 0. And from here, I'm going to obtain CY as 10.25. Sorry, 25. It's going to be written better. Yeah, 25 kilonewton. And also I have a total Fy equation to determine the By. Total Fy is equal to 0. And the 24 minus CY and minus By is equal to 0. And By is going to be equal to 13.75 kilonewton as the reaction force upward direction. So now I got the shear forces. So let's draw the shear and the moment diagrams. So it's going to be something like this. For example, this is B, this is A, and this is C. I have at A as a shear force 6.83. So for example, this is 6.83. Okay. And I'm gonna continue with the same amount because I don't have any forces, but the midpoint of the beam I have at 20 kilonewton as the force. When it applied as 20 kilonewton, I'm going to decrease to the point which is 13.17 now, and I'm going to reach the point B. Okay, at B I have a 13.17. When I apply the 13.17, I'm going to reach the point 0, and I have another B as 13.75, and I'm going to reach the 13.75. Okay, so this is 13.75, and I have here as a distributed load. Let's check. 3 multiplied 8 is 24. I'm going to decrease as distributed load. So it's going to be decreased as triangular. When I take the summation of 24 minus 13.75, it's going to be equal to 10.25. So it's going to be something like this. For example, this point is going to be 10.25. Now this is the shear diagram. So positive, negative, positive, and negative. Okay. So let's let's draw the moment diagram also. I'm going to draw the moment diagram here. This is B, A, also C. So now there is no any moment at A, let's check. Look at here, there is no any moment at A from A to B. So I'm going to start with 0, and I'm going to increase at this amount of area. Okay, so and this is going to be, I guess, 4 meter, and this is 4 meter, and this is X, this is 8 minus X, and X is equal to 4.58. I guess you know how to determine it. So I'm going to increase at this amount of area, and I'm going to reach the force applied. The force applied. It's going to be as linear as triangular, the shape of the moment, because the shape of shear diagram is rectangular, and this is going to be 27.32, and then I'm going to decrease at this amount of area. For example, it's going to be something like this, and I'm going to reach the 25.33. Okay, when I decrease at this amount of area. So now again I'm going to increase at this amount of area. When I increased, I'm going to reach the point as 6.30. Yes, when I increase at this amount of area, I'm going to reach the point which is 6.30. Okay, and then I'm going to again decrease at this amount of area, and I'm going to reach the point 11.33. Sorry, for example, this is 11.33. Now also this is the moment diagram. And now the question is solved. I guess you understand how we are going to solve the moment distribution of the as a beam questions, and how to draw the shear and the moment diagram of these beams. So if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. See you for the next question.